3, 2, 1.
Hey everyone, you're currently watching a 3D rocket shot that was back in 2020, and here it is 2023, and we wanted to revisit the same project. We came up with two different scenarios to test the same rocket. So we planned to do two different scenarios for this rocket, the first one being a vertical launch, and the second one was a horizontal launch. On this rocket, it was designed by Landrew, and a link to the files are in the description. So a little bit about my 3D printer setup. I currently have an Ender 3 Pro. I was able to print the base and the first section of this rocket no problem, and then somehow my Z-axis got thrown off. It took me a little bit to figure that out, but after that I was able to finish the prints no problem. Overall, the printer rocket the same size as the one I did would take roughly 2 days if you're using the similar printer to mine. The reason I like this rocket design is because it's modular, and you can make it whatever size you want. As far as hardware goes in this rocket, all you need is a small 440 screw, and it screws into a little blue cap that screws into the nose cone, and it's what attaches your parachute. Being made out of 3D printed material, the rocket weighed a little more than your normal hobby rocket. In fact, mine weighed 126 grams. I used a C rocket engine to fire it. In fact, mine was a C6-5. It was able to shoot this rocket up to about 550 feet. There's a spot in the bottom of the rocket that it slides into, and it holds it pretty snug. Okay, without further ado, we're going to roll into the live vertical test.
3, 2, 1.
So as you can see from the vertical flight test, it took a hard right. I was able to calculate the velocity. It was going about 29 meters per second, or 90 miles per hour. So before we roll into the horizontal flight test, I was going to talk about the setup. I used 4 metal fence posts, 2 on each side, and then I ran a few hundred feet of 45-pound fishing line. And then once I got it as tight as I thought I could get without breaking it, I put the rocket on it. So now that we know a little bit about the setup, we'll go ahead and roll into the live flights.
3, 2, 1.
So as you can see from the horizontal test, it didn't go as planned. I expected it to go a lot further, but I believe the fishing line was too stretchy, so once the motor kind of stopped pushing, it just stayed in place. So since I had some spare motors and matches, we decided to do one more test. We propped the rocket up at an angle and decided to see how well we could aim it.
2, 1. 2, 1. Three, two, one.
Overall, this 3D printed rocket's pretty reliable. It was fun to print and shoot. The only thing that you might have to repair on it each time is the bottom half, because the motor's so hot it contracts the plastic, so each time it's harder and harder to put the engine in. And because it's so modular, I mean, all you gotta do is print another one, and if a section breaks, which mine broke on this shot, all I have to do is 3D print another one and I'm good to go to shoot it again. This was a really fun project. I probably will be going back to the horizontal shot eventually to see if I can get the fly right. Until then, we'll be doing some other projects, so see y'all.